Now we are going to discuss the other metrics like precision and as I mentioned to you, where we usually for classification we will check the accuracy. But for recommendation system, most of the people said that precision and recall will be better. So you can see here, recommendation is viewed as information retrieval task. Okay. We call the information retrieval means when we extract the information, we want to know the information that we extract, or we can say the retrieve items, whether it is good or not. So retrieve or recommend all items which are predicted to be good. We call precision is a measure of exactness. It determines the fraction of relevant items retrieved out of all items retrieved. Maybe it is a little bit uh, confusing about this one, but you can see from the confusion matrix. So let's say we have the actual and we have the predicted. The actual is good and the actual is bad. And I want to know what is the prediction. If the prediction is good or the prediction is bad. Here, the precision means the true positive. Okay. I hope that you already know the TP, TF, TN, FN. Okay. So TP means true positive. It means when we know the actual is good, the prediction is also good. So this is the true positive. TN. TN is true negative. True negative means when it is the actual is bad and the prediction is bad. What about FN and FP? FP is false positive. False positive means the actual is positive, but the prediction is bad. Wait, maybe I can see you this one. So you can say it's all positive. Now, using this one, so using this confusion matrix, we can do this. Okay, you can do this one. TP divided by plus P. So it's recommended or the numbers. Okay, so here is the number. the number of good movies recommended divided by the all recommendation. So we call the TP plus FP is all recommended items. Recall, meanwhile, it is a measure of completeness. So this one is a measure of exactness. It is a completeness. It determines the fraction of relevant items retrieved out of all relevant items. If we say this expression is the proportion of recommended movies that are actually good. So the movie good and it is recommended. Okay, so there are two categories. When you recommend movies or when you recommend the item, it can be good item or bad item. What does it mean by good item? So good item, if you could buy or if you purchase the item or if you watch the item. Okay, so it's, yeah, we call it, it is good. But if it is bad, then you may see the user dislike. If the user dislike, that item is bad item, or the user did not purchase it, so it is also considered as bad item or the reverse of good item. So if we can distinguish this category, good and bad, then we can also make the category of recommended and good. Okay. Recommended and good. So here, if we recall is the proportion of all good movies recommended, the proportion of all good movies recommended divided by all good movies, the P plus Fn. So Fn is false negative. So the prediction is negative. The prediction is negative, but actually it is positive. So false negative. So this is a graph to show the comparison between precision and recall. So typically, when a recommender system is tuned to increase precision, recall decrease. When we try to increase precision, when we try to increase precision, the recall decrease. So that's the idea. It is typically, okay, or vice versa. So if we want to increase the recall, the precision decrease. So that's why you can see the graph usually something like this one. And we will have other measures like AUPR and AUC. AUPR means the area under precision versus recall. So this is the area under precision versus recall. And there is also another chart, we call it area under ROC. This is based on the operating curve. We want to check the difference between the TP, the true positive, and the false positive. So this is an animation. We can look at it. is the actual, label. So you can see here there are 10 data, and we have also 10 data plus 1. For example, this is like, and minus 1, it is dislike. So we can have the number of users who like the item is 10, and the number of users who dislike the item is 10. And I want to predict. I have 10 data like and I have 10 data dislike. If the model is good, then if the actual is positive, the prediction, I hope it is also positive. So I hope that it is 10. If the actual is negative, I hope the prediction, when the model is good, I hope that the label here is also 10. So if it is 10 and if it is 10, that's our expectation. Then the accuracy will be 100%. But as a matter of fact, it is impossible to get 100%. So there might be some errors. So we can see here, if the actual label is positive and the prediction label is positive, yeah, we have 10. And the negative is 0. When the actual label is negative, the prediction positive is 3 and the negative is 7. So you can get the recall. The recall is 10 divided by 10. It means this one, from 10, that is true positive, we divide with the total, that is actually recommended and positive. Precision is the true positive divided by the total of data that has been recommended as positive. So it is 13. So you can see the result is 13, like this one. Then if we try to simulate, so let's say if you can see here, the precision will be about the actual shifting. So if the actual label is positive, we want to know if it is positive or negative on the prediction. So if it is high, then of course that is our expectation and we will get the AUC is 100%. But if it is not, then you can see how the AUC effect has been affected by a different result of the prediction. When the prediction on the positive is different, so it will affect the precision. And it also affects the recall. But if it is only the negative, then it only affects the recall mostly. So this is what we want to measure about the AUPR. When we have the recommended items and the good items, so we need to check this one. What is the pattern of this precision versus recall? And in the recommendation system, we cannot say we want to recommend only one item. usually we will have precision at k. We have precision at k. Recall at k. What does it mean by at k? At k means it is a fraction of top k recommended items that are relevant to the users. So we have k items. When we recommend, we cannot recommend only one because users will have different flavor. Users will have different tastes. Then we need to recommend top k, maybe 5 items, 10 items. So P means the number of top k recommendations that are relevant divided by the number of items that are recommended. So it is the same with the previous one. And recall, we also have the at k. In some papers, okay, you will see hit ratio. So the word recall is similar with the hit ratio. It is a fraction of top k recommended items that are in a set of items relevant to the users. So why they call it hit ratio? We want to know if, let's say in the online shopping, when you recommend items, so we want to know whether the user will click or not. So that's why they mention it as hit ratio. If you hit it, then the recommended items is correct. And this is the hit ratio at k. So the top k items, if it is top k and if it is correct, then the hit ratio also will be high. Note that the larger k is the higher hit ratio, since there is a higher chance that the correct answer is covered by recommendation. So let's say if you want, if I want to recommend items, if you recommend 5 items, and if you recommend 10 items, which one is better? If you recommend 10 items, means there is a higher chance the correct answer is covered by recommendation. So if there are 10 items, then there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 items. So suppose, okay, the user like the item number 10. Then we are lucky. We can say that our recommendation has a positive effect. But if you have only 5 items, so the chances is lower than when you give the recommendation with 10 items. However, the measures will be also different. If you have a lot of recommendation, of course, there are some like trade-off. Okay, the higher K, maybe the higher computation or the lower recall, even though we can have the higher chance. So let's say we have this example. I have 10 items. A, B, C, D, E, F, G, H, I, J. Now, based on the recommender system, we can see that there are 5 items that has been recommended. 5 items that has been recommended. And let's take a look the details on the user A. So the user A, from these 10 items, actually, he likes item A, B, C, H, I, J. So the like button, it means the user A think that this item is relevant. This item is good based on the user A. If there is no like button like this one, then it means the item is not good. The item is not relevant to user A. Then how can we measure the precision and recall? When we use the precision at 5, it means I have 5 recommended items, and from this 5, I want to know what is the precision. From the yellow items, 3 items, 3 items out of 5 items are correct. Then we can say this precision at 5 is 0.6. What about recall? The recall means the relevant items 3 is in the recommended items out of 1, 2, 3, 4, 5, 6. Out of 6 that are relevant to the user A, 3 of them are in the recommended items. Then, okay, based on the recall, it is 3 out of 6 items. The result is 0.5. Yeah, we can do with this precision and recall. Yeah, you can have precision at 6, so it means 6 items, or you can have precision at 10, and it means among the 10 items, and etc. Okay, there, let me stop. Let's have a break. Okay, I will continue after the break.